So in this video I'm going to talk a bit about experimental design and how to design an effective experiment carry out in such a way that gets you accurate and reliable results and allows you to draw effective conclusions from them. So the first thing you need for any successful experiment is an objective. And what this is saying is, well, what are you trying to achieve from doing this experiment, and how will you actually know if you've been successful? So to give an example for this, some of the ones that come up in the AS course are calculate the resistivity of this particular wire, or investigate the effect of increasing length on resistance, or if we look at the A2 course, maybe carry out an investigation to measure gravitational field strength at the surface of a planet. That sort of thing. So those are your objectives, that's what you're working towards. Next thing you need are the variables. So these are the things that you're going to be either changing or measuring or controlling in your experiment. And I've got a glossary of some of the key terms at the bottom as to what the different types of variable are. So independent variables is the thing that you're going to change in your investigation. Maybe you have something that has multiple settings. I don't know, you're going to change height from which you drop a ball, that sort of thing. So that's the thing that you go about changing. And the dependent is the thing you measure. So if you're doing a gravitational field strength, you might change the height from which you drop the ball and then measure the time taken for it to hit the ground. So that's the thing you measure, that's your dependent variable. In terms of things you control, there are lots of different types of this. So you're thinking about, if you're dropping balls, making sure you're dropping the same ball so it has the same surface area, so you're getting the same air resistance each time, using the same measuring equipment, that sort of thing. So those are your control variables, and maybe you want to take all your results in the same location at the same time, so you don't have things like temperature variation or wind variation, that sort of thing. So those are the ones you're going to want to control to make it a fair test. So the third step is actually selecting your equipment. So once you've identified the variables you need to measure, you need a way to actually go about measuring them. So whether you're using a ruler with millimeters or if just centimeters is appropriate, or if you need something to measure angles like a protractor, or you need something more accurate using trigonometry or vernier for instance. So it's about selecting the one with appropriate precision. Obviously, if you're measuring something in kilometers, you're not going to use a meter rule, you're going to use some other kind of distance measuring device. And it's about selecting one that's appropriate for your experiment, so it has the appropriate precision for your experiment. And we've got here a glossary of what precision is at the bottom. Once you've got your variables and you've got how you're going to measure them, you might in certain circumstances be using an equation to process that information. So an example of this is if you're wanting to work out resistivity, how you go about doing that is actually measuring the potential difference and the current in the circuit, and using those you can work out resistance. So then it's important in your plan to set up, well, what equation am I going to use? And then you might want to rearrange it into a format. So for instance, when I was talking about like resistivity or something, the standard equation is this way. But if you're wanting to calculate resistance, then you'd rearrange it, obviously. And then, so you need to have this in your plan. I'm going to take these measurements and then use this equation to calculate this other variable. So then we need to think about making the investigation valid. Now, this is about taking a range of data. So for instance, if we're looking at gravitational field strength again, you're asked to work out over a range of 0 to 100 meters above the surface of the planet. You would take one reading at 0. You would take another reading at 100. And then what you do is you take 5 evenly spaced. Okay, so that's how to deal with if you're asked to take over a range. But less specifically, it's about having a set of results that allow you to plot a decent graph. So the rule of thumb on this is you need 7 or more sets of data to have a valid experiment. And this is not including repeat readings. So if you've done the same one twice, that's not 2 sets of readings, that's still 1 set of reading. You need to do that another 6 times on top of that first one. Next thing, making an investigation reliable and accurate. I think even from year 7 people tend to know that you want to make an investigation reliable, you take repeats. But what a lot of people miss out is to make it reliable and accurate is about taking repeats, so you've done the same measurement 2 or 3 times, and then you take an average of those repeats. And that's about making it accurate. Again, we've got our glossary of terms at the bottom. You need to have a look at what these terms mean. But it's about taking those repeats and then averaging them. That's how you make it the reliable and accurate experiment. So this is the step a lot of people miss out. They go through the stages, they select the variables, they've got their equipment, they've talked about their equations. They don't actually say what you do with the results. So in most experiments you'd plot some sort of graph because that's what allows you to observe your data and notice any patterns and trends in it. And so this is something you should be thinking about in your design for an experiment. Obviously, well, what kind of graph would I draw? What would I plot against what? And you do need to be nice and specific here and say, I would plot this on the x-axis, this on the y-axis, and look for a trend. Or in the resistivity experiment, you'd be looking to calculate the gradient and find the y-intercept from that graph, that sort of thing. So it's what graph you need to plot and how actually are you going to use that graph to meet your objective that you set at the start? Whether you're going to do some calculations from the graph or observe a trend, that needs to be outlined in your plan. So the last thing a lot of people miss as well, actually the steps to reduce error in your experiment. What are you personally doing to try and minimize error in your experiment? So a lot of people give very vague statements like, oh, I'm going to take repeats or blah, 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 blah. That's absolute nonsense. So thinking of steps to reduce error. So if you're measuring field strength and you're dropping a ball, a step to reduce error is, well, you think about what could cause error. And one of the things that comes up is air resistance. So what you do, your step to reduce the error is to have a ball of very small surface area to minimize air resistance. So that's an example of a step to reduce error, and there are lots of them. So in circuitry we quite often say that we'd make sure to unplug the equipment between tests so it doesn't get hot and change resistance, that sort of thing. And those are things that you really need to think about in your experimental design and something you should be prepared to answer as part of your plan. And those are the 8 stages to designing a successful even experiment.